Hi again, my dear students and YouTube followers. We will see now Unit 7. Unit 7 is about general equilibrium, okay? And I hope you like as much as I do. Question number 1. If initial endowment W for two consumers is Pareto efficient, then it should not be any trade. Correct. If it's Pareto efficient, at least one of them will lose if they change, if they exchange any quantity of good between them. Okay. If one consumer improves with any trade, the other one will be worse off. Yes, of course. That's the definition of Pareto efficient allocations. Yeah. W will lay at the contract curve. Yes, because the contract curve is the set of Pareto efficient allocations, and we've said that this W would be a Pareto efficient allocation. Okay, now if consumer A's initial endowment is 7-8 and consumer B's initial endowment is 5-10, consumer A will demand more from good 1. We don't know even their utilities, so we can't know nothing about the final demands. Okay, so A and B are clearly false. And about the size of the Edgeworth box, well, consumer A has 7 units of good X, yeah, and consumer B has 5 units of good X, so 7 plus 5 are 12 units of good X, and for good I they have good Y, sorry, they have 18. So clearly is D. Perfect. The set of possible final demands after a trade between two consumers that share two goods is called contract curve. Yes. Pareto set. Yeah. Pareto efficient allocations. Yes. So we may call any of these ways. Okay. Now, number 4. Consumer A's utility function is this one. So X and Y are perfect complements for consumer A. And consumer B always is ready to exchange 1 unit of X for each unit of Y. We should say for each unit of Y, okay? No matter the quantity of each good he already has. So for consumer B, X and Y are perfect substitutes and at the rate 1 to 1, okay? The initial endowments are 2 and 3, while for consumer A, while for consumer B 3 and 2. Then the contract curve is, okay, we know that when we have one of the consumers with perfect complement, then the contract curve will we will find it by equalizing these two components. Okay, now XA equal to YA is the correct answer. Sorry. Now, well, here you have the graph, the Edgeworth box, but it's not necessary for such a easy question. Okay. This is the explanation. I've told you many times in class. So here you have the graph if you want to look at it for some time and maybe find something you normally can't find. 5. Consumer A's utility function is this one. Consumer B's rate exchange. Oh, these are the it's the same situation as before, but now the question is the price or price ratio at which the trade will be done. Okay. Now we know that the consumer with perfect substitute will tell the price at which the exchange will be made. Okay, then as consumer B has perfect substitute preferences, then the price ratio will be its MRRs, and the MRRs is 1 divided by 1, so 1. Then we should mark D. Okay, now see, consumer A's utility function is this one. Okay, the same exercise. And now the question is the Walrasian equilibrium or final demands. Okay, how many units of each good will they finally carry from this meeting? Yeah. Now we know that the demands from substitutes are not very useful. Okay, so what do we do? We go to the budget constraint or of consumer A, and we can find the quantities they he or she will demand. Okay, the budget constraint is the price of X times quantity he will demand from good X plus price of Y times, so 1 the price. Okay, and now as the contract curve is this one, we just substitute it here. Okay, we substitute here the I should say the budget. Sorry, the budget income is consumer A has 2 units of good X, each of them at the price of 1, and 3 units of Y, each of them at the price of 1 also. So he has 5 as budget. Yeah. Now, as X is equal to Y for consumer A, we substitute it here and we find this. Okay, we find this. Then what we are doing here is the consumer A's utility maximization problem. Okay, we find this X equal to Y from the equalizing the 2 components of the mean function, and then we carry it to the budget constraint. Okay, well, just in case you can see maybe that I'm doing a different way as I usually do. At the end I'm doing the same. Okay, then consumer A will demand 2.5 and 2.5. Okay, then as consumer B has perfect substitute, and I repeat, it's the indifference curve, the demands are not useful. We just say that consumer B will demand the rest. Okay, the rest, the units the consumer A don't demand, so doesn't demand. So XA plus XB equal to 5, because there are 5 units of X, there are 5 units of Y also. Then consumer B also will demand 2.5 of each good. Okay, then we have the graph, the Edgeworth box. Okay, initially this is the endowments, yeah, or the endowment allocations. So this is the final equilibrium, exactly at the center of the Edgeworth box in this exercise. This is the price line, that is one of the indifference curves, indifference lines from consumer B. It has substitute preferences, and we can see that consumer A demands 0.5 units more of good X, and instead he's giving 0.5 units of good Y. So the exchange is at price 1. Okay. More. Regarding the price line, which of the following is false? The cheaper the good X is relative to good Y, the steeper the price line is. Well, this is correct. Sorry, I thought it was saying here the more expensive. Sorry. The cheaper the good X is relative to good Y, the steeper the price line is. No. Remind that the slope of the price line is the price ratio. Okay, and we usually use the price ratio, define the price ratio as px divided by py. Okay, so the cheaper the good X, the less or the lower the price ratio would be, so the flatter the price line would be. Okay, it tells us all the allocations at the Edgeworth box that could be achieved by pure exchange at the equilibrium, starting from the initial endowment allocation. Well, correct. In fact, we could say that. Oh, sorry, but here we need to find the false. I'm so sorry. So the false is A. The false is A. Okay, then these are true. Here it's not only the equilibrium that we can find. We can find all the possible bundles or the possible combinations starting from W that can be achieved by doing the exchange, the trade at the equilibrium price. Okay, and one of them exactly the intersection with the contract curve is exactly the final Laurentian equilibrium. The cheaper the good Y is relative to good X, so the more expensive the good X is, the cheaper the price then is. Yeah, correct. Okay, so the false is the first one. Sorry. Well, now number 8. Select the correct statement. The contract curve always goes from one corner to the Edgeworth box of the Edgeworth box. Of the Edgeworth box to the opposite one. No, this is false. This is false, and we've saw many times. The consumer who has perfect substitute preferences will consume generally only one good. This is not correct. This is not correct, and I've told you many times in class. The initial endowment allocation can't be the competitive or Walrasian equilibrium. Of course, it could be. Of course, it could be. It could be that the initial endowments are perfect. Are Pareto optimal, and so there is no trade between these consumers. Okay, so A, B, and C are false. It should be D. If both consumers have Cobb-Douglas utility functions, the competitive or Walrasian equilibrium will be inside the Edgeworth box. Yes, this is true. Look at the graph. If both consumers have hyperbolic indifference curves, so coming from Cobb-Douglas type utility functions, the tangency condition will always lay inside the Edgeworth box because these hyperbolic functions don't touch the axis. Okay, they are asymptotic. So these tangency points, they will lay for sure inside the Edgeworth box. Now the 9th. Select the correct answer considering the following graph. Blue indifference curves are from consumer A, here, person A, and the black ones from B, here in the northeast. The point at the Edgeworth box M is Pareto optimal. Okay, we can't confirm that it is Pareto optimal. Okay, we can't say it. We don't have the evidence that this tangency point between two indifference curves. Okay, it seems to be, but we can't confirm it. The point at the Edgeworth box W is Pareto optimal. Of course not. I teach you this every time we begin unit 7. Okay, if starting from W the consumers change, for example, to M or to any bundle here in this blue zone, both will improve. Okay, both will improve. Consumer A will be in the more northeast indifference curve, so better off, and person B will be in more southwest indifference curve, so she will be better off. Okay, then W is not Pareto optimal. Both consumers prefer M rather than W. Yes, I've just explained you. Okay, M is preferred for both consumers than W. Sorry, but we can't say A. Okay, we can't confirm that it's Pareto optimal. None of the above is true. Okay, we should mark C. Now, the last one before a little break. The price of a pure exchange between two consumers will be set by, be careful, the price of a pure exchange. The price will be set by the government? No. By an agreement? Well, no. It's an agreement between both of them, but the consumer from whom the goods are perfect substitute will set the price. Okay, if there exists. Okay, if there exists such a consumer, then we mark C. Okay, we know that the one who has perfect substitutes always wants to exchange the goods at a certain rate. Okay, so let's make a little break and we continue with question 11.